Okay, here's the next one that we have. All right, and it was, what we have to do is find the normal force. Okay, then when we find the normal force, then we can find the frictional force, because there's two forces being shown here. Those are two like external forces. Now the actual thing has, of course, gravity's pulling on it this way. The Earth's pulling it this way. The table is pushing up on it this way. So that's the normal force, which is perpendicular to the surface there. And then there's a frictional force that's implied here, because it says it's got a coefficient of kinetic friction. So it's actually going to slide. It's going to be sliding along and with an acceleration. All right? And it's got an angle of 30 degrees. So pretty straightforward. Let's take a look at it. All right? It's this guy. And I know my hand is huge on here, but anyway, so those are our variables. So let's just draw. Let's just draw the things that are. One of the things that I showed the students yesterday is when you got a cattywampus force like this, let's just draw it this way. And so it's coming in like this. Let's just move it down here. And they're showing this angle. So that is this angle right here. Did you ever think you'd use alternate interior angles again once you left 9th grade, 10th grade geometry? Well, there it is. So it's coming this way. That angle theta, which is 30 degrees, is that way. And then we've got F1 going this way. And then a frictional force going this way, mg coming down, and a normal force going up. It's not flying off the table, but we know it's got to, but to find the normal force, here's what we do. Sum of the forces in the y direction are equal to 0. It's where we kind of start with a problem like this. And I've got a normal force minus mg. Now there's one more force here. I've got the x component, or the y component of this force here. This is F1 of y. And this is F1 of x. All right? There you are. Here it is. Okay? So this would be minus F1 of y. And so the normal force winds up being this mg. Let's do the algebra, add those to both sides. Minus F1 of y, where F1 of y F1 of y is equal to F1 times the sine of 30. Or the sine of theta in this case. All right? Oh, it's plus. Ah, there we go. Bring them both over. There you are. So now that's the normal force. So that's not bad to find. So we got mg plus F1, whatever F1 is, sine of theta. That's your normal force. Now, that gives us, now we can also find now the kinetic frictional force, the magnitude of it, which is equal to mu of k times F of n. So we've got a number for F of n. So now we look at the sum of the forces to solve for A. Sum of the forces in the x direction is equal to, this is actually the acceleration in the x direction. MAX, what are the forces here? Well, we've got F1, which is positive, minus, or was this F2? I'm sorry. Oh, that's an F2, my glasses. I should probably start over, but I'm not going to. Positive F1 minus F2 of x is supposed to be F2. All right? Minus F2 of x minus the frictional force, F of k. Well, I've got numbers for everything here. All right? And so then x is equal to the sum of those forces in the x direction, which we've got numbers for all this stuff, where we can plug in stuff for all of that stuff. divided by the mass. And we're done. All right, so that one's not too bad.